Hello everybody, I'm Scott from 5013X, and I'm going to be doing an explanation of our mid-season or states robot. We've had it at two competitions, well, three technically, but it's gone through some changes through them. And yeah, so let's get started with our drivetrain. So we're running a 600 RPM 2.75-inch wheels on 6 motors. It's quite fast. We've been able to get some cool plays out of it, some like negative corner plays, some last second wall stakes. I would highly recommend if your robot weighs under 13 pounds to use this drivetrain, but we're going to be switching for Worlds just to a 3.25, 450, just because we want to add some more weight to our robot. And also our odometry here. So this is our odometry that we absolutely love, and I haven't seen anybody else in high school do it. I think there's one other team, but I haven't actually seen it. So this is just vertical odometry, so it's just vertically sliding with using 2-inch wheels and then these laser cut pieces that look like this. So it's very, very simple. It just slides up and down in this little crevice here, and it gives it enough to where it can like move all the way down. So if we ever tip, it can still keep good contact with the ground because they're nice and banded down. They're a little beaten up now, but they work pretty good. If you have 2-inch wheels or access to a laser cutter or CNC, I would say definitely use these. And I think they work with 2.75-inch wheels, but I actually haven't tested. I've only used these with 2-inch wheels. But yeah, definitely recommend using these. They're very compact and very effective. Moving on, we'll talk about Mogo clamp. So we're just using a pretty simple push down clamp. I'll show you it in action. But we also have a distance sensor right here. So we use this distance sensor for programming. We didn't like to use it during driver just because we wanted to have more fine control over when we were clamping it. But when we were using autonomous, it was nice to have just so we didn't have to clamp at the exact right second. It would just always clamp whenever we needed it to. So here it is in action. And then it also works on any angle. So any other angle it works. Even right on the corner, it still works. We're a little bit low on air right now, but it does work very well. And then it's just a boxed L channel. Quite simple. We have some funnels at the side, but there's no complicated stuff to it. Just 2 pistons. And then moving on to our intake, we have a hooks, mostly hooks, but it has like a cool first stage here. So most people just run this first stage, which we did originally have, but then we added that odometry in there, and we realized sometimes our hooks could get caught on it. And we were right on the edge. If we moved our hooks any higher, we wouldn't be able to get a good intake all the way through. So what we did was we just added the second stage. Pretty simple, just 2 pieces of Delrin and a chain attached to it. And it works really well. Gets it all the way up there. And then, so this is just fully polycarbonate. I think we're going to switch to having just an L channel on there just to give it a bit more structure, because sometimes it'll bend a little bit too much that we don't want. And we have this ramp on the front just for clearing corners. It worked great. We could get some bonus points during autonomous. And it's also running on a 5.5 at 400 RPM. So originally we had it at 600, but the geometry of it isn't perfect, and it was sometimes bogged down a little bit, and 400 works great. We never have any issues with it. It always picks it up from the floor whenever we need it to. And then we also have this intake lift here. So this just lifts it enough to get... So we could do 2 things with this. First of all, in the middle of the field in front of the line stake, we could pick up there, but we could also pick up in the corner. So we could pick up the second ring and stack in the corner. Just the way it works, it gets it at the perfect angle where it can still ramp in. So we can drive in, pick up the first one, pick it up, and then get the second one, so we can get both from the corner at the same time. Then moving on to our hooks here. So this is another tech that I really like, that I would highly recommend if you have extra polycarbonate, which you should, to build. You just do a second hook stage here on the bottom, so it's kind of like inverted. This just stops it from bending back, so you can run your chain a lot looser to have like less friction, but still have enough grab on the ring to be able to fling it down properly. And then another part we have is our color sort right here. So this actually works a little bit differently than how some people do it. Some people just do it where if it detects the other color, and then sometimes they maybe have like a separate distance sensor to test it. But we run it all in one, because this actually can track distance. Not precise distance, but it can tell you if it's close, near, or far. So how we have the code set up is, here, let me grab a ring here. We first bring it all the way in, and only when it's right above it. So it first checks distance, make sure that it's right in front of the sensor, and then it checks for color. So this was very consistent, worked out through the whole tournament, other than quarterfinals, which lost us the match because of it. But other than that, it worked very consistently in almost every single lighting. So we're pretty happy with it. Here, I'll get a blue ring to show you. But here. So it stops just at the top before scoring it onto the goal. And then moving on, I'll talk about Doinker. Let me rotate the bot around. I'll talk about our Doinker next. So this is our Doinker here. It's banded down and it's pistonized up. This is because it's not only a Doinker, but it's also a goal rush. So obviously we have this bar here for clearing corners, but we also have these little notches right here. And these just kind of wedge into these little crevices underneath the goal. So we can just drive up to it, press the button, and we're a little low on air right now, so it doesn't pick it up all the way, but normally picks it up to about there. And we can just drive backwards with it, and it gets a nice good grab on it. Now, we only ever actually fought somebody once, and we ended up winning. We actually tied to get to the goal, but because we had a longer timeout, ours stayed strong and pulled it away from them, and we ended up scoring there. But yeah, fortunately, it works pretty good, so we're pretty happy with it. And then our last two parts is our Lady Brown and Hang. They're kind of built into one. So this Lady Brown, we're running on 50 RPM. So it's just a 5.5 watt motor running on a 12 tooth to a 48 tooth. So you can see we had to use a custom piece of polycarbonate here to get that gear ratio to work, just because these don't actually mesh perfectly on a normal C channel. So you'll see it still gets a pretty good speed, but still has enough torque. So works pretty quick. But if I press it once, it just goes to the load position. Then I press it again, and we can score on either wall stakes or alliance stakes. It just goes to the right spot, and then it goes back stowed away. And then also, so our Hang kind of built into the same thing right here. It just deploys pretty passively, just with rubber bands, and can hang on the bar pretty easily. It worked most of the time, other than one time one of the fields was like way off, like the bar was like almost an inch too high, which kind of sucked, but it is what it is. And then I guess the last thing I'll talk about is wire management and weight savings. So these are two kind of just quality of life things that we do on our robot. First of all is our cable management. It kind of keeps our cables all tucked away just by taping them all up until they get to where they need to go. So it also just makes the bot look a lot nicer. And weight savings. This bot weighs about 12.5 pounds, so it's quite light for being a fully built up bot. It probably could be lighter, but it's pretty good. So we use nylon screws and nuts wherever we can. And we also use these I think they're from McMaster Car. These right here, they serve as replacement for the nylocks, and they actually work really good. So once you put them on, we've never had any issue with them coming loose. So you can see we have them all over the robot here. And in combination with that, you'll see we have these flathead screws, and these serve as aluminum screws. So they're about 1/3 the weight of a normal screw, and that just kind of helps us save weight throughout the whole robot. And also we use L channels, or these are half cut 3 wide. So they're about as strong as a normal C channel, but they weigh close to half as much. So they're very nice. I'd recommend using these if you have any sort of way to cut C channels. But yeah, that's all. Thanks for watching. Hope to see you guys at Worlds.
Go.